Hey guys, and welcome back to this third video where we are looking at objects where the sum of all the forces is equal to zero, or your teacher might say the net force is equal to zero. Either way, first condition of static equilibrium. Sorry, my throat's getting a little raw right now. So in this problem, students always get me to work it. We've got a leg that weighs 200 newtons. And then usually what we're given one of the two counterweights. So let's say that counterweight number one, let's say that counterweight is 125 newtons over here. So if we start doing our free body diagram, and I gotta be honest, I would rather you take this and draw your own free body diagram. So let's do that. Ooh, you've got mail. So we're gonna say this. We've got a W2 at some unknown angle of alpha. And then we've got a force. I'm just going to go ahead and write it. 125 newtons at an angle of 40. And then we've got going down a 200 Newton. Again, for me, I like to call that an mg. Some people call it mg's, whatever. Guys, here's the thing. The physics in this problem, if you're watching this video, you should totally be killing the physics in this problem at this point. The physics would be, I'm going to define that as positive to the right. I'm going to find positive is also up. So I'll look for any force that's pointing right, and that's my W2. So sum of the forces X would be W2 cosine of the angle, and now subtract anything working against it, and that would be a 125 force at 40. So I'll subtract 125 newtons cosine. And again, I did leave my units out. Someone can gripe at me later, but I did that simply because it's easier to solve the problem. All right, now let's do sum of the forces y. So look for anything that's pointing up. We've got a W2 sine alpha. And I said this as a hint a little while ago. When you're doing these problems, if you've got a W2 cosine alpha in one expression, you have to have a W2 sine alpha in the other, just like this 125 cosine. If there's a 125 cosine in this expression, there's got to be a 125 sine in the other. And we look, now both these forces are positive in terms of y. So I'm going to add this 125 Newton force, sine of 40 degrees. Now I need to subtract anything working against it. And that's the weight of the leg, which is 200 newtons. Oh, I don't want to connect anything. Go away. Go away. Computer, leave me alone. Stop it. Thank you. Minus 200 is equal to 0. And guys, here's the thing. The physics in this question is over. What makes it hard is the fact you have two unknowns. We got two equations. It's just you may not be used to this sine and cosine. Guys, if I look at it, I'm going to start thinking identities, things like that. The easiest thing for me to do is take the simplest of the two expressions, which is W2. So let's knock this out. W2 cosine of an unknown angle alpha, and let's add 125 cosine 40 to the other side. So we'll break out our calculator. 125 cosine of 40, 95.8. So then we'll just set that equal to 95.8. So again, all I did was solve 125 cosine 40, bring it to the other side. Once I've done this, let's just solve for W2. W2 would be equal to 95.8 divided by cosine of alpha. And I'll tell you why I solved this one. I got a couple of reasons. And guys, now it's like any other problem where you have multiple unknowns. We're going to take this expression for W2 and plug it back into our other formula for W2. So now we'll have 95.8 over cosine of alpha times the sine of alpha. Hopefully you're already going, I so get this, and I'm done with your video, Mr. Cole. Oh, cool. Be sure to like, comment, and subscribe, yada, 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 right? All right, 125 sine 40 is 80.3. So we've got plus 80.3 minus 200 is equal to 0. All right, guys, here's the thing. Sine over cosine is tangent. So what we've got here is 95.8 tangent of the angle is equal to, let's do a little combining here. What have we got? 80.3 minus 200. Move it to the other side though, and we've got 119.7. And hopefully you know how to solve for this already, but we're going to divide both sides by 95.8. Divide both sides by 95.8. So let's do this. Divided by, I know my negative's still in there. I'm not too worried about it. So I end up with tangent alpha is equal to, a calculator that disappeared, what, 1.25 is equal to 1.25. And now if I want to find the angle, I'll take the inverse tangent of both sides, and I'll have tan negative 1 of 1.25. And guys, that's it. So I said, if you understand everything, you could quit. I need to make sure and use this number exactly as written though. So my angle is 51.3 degrees, guys. That's my alpha. If you want to know what W2 is now, I'm not going to solve for it because you should be able to do it. All you would have to do is take your angle of 51.3 degrees, plug that back into our first expression, and 95.8 divided by cosine 51, and you'd have your solution to W2. All right, guys, I hope this was a pleasant physics experience for you, and I hope to catch you watching more videos on this channel. Love you guys. Bye. Bye.